Hello everyone, Assalamualaikum. Welcome back to my channel. So now we are going through our practice exam. So this question are mimicking the real test in the ACS exam. Let's do it. So because we already knew some concepts in the first part, now we are going to do it quickly. I mean, quick, like faster rather than study questions. Yeah. All right, now let's get started. Okay, so the first question: arrange this range CSPR and ACLRBPR in increasing magnitude. Okay, we need to know first like which one that the smallest one. Okay, so like I mentioned, guys, we need to know. Okay, for the lattice energy. So at this energy is the energy, right, that release to the energy release when ions come together and forms. Okay, and forms. So this is the definition of lattice energy. So the equation, like I'm like we are to like we did for from the previous question. So we know that L is Q1 and Q2 and then R. Okay, so this is the basic of equation in to determine the lattice energy. So as you can see, lattice energy like linear with the charge. Okay, and then L like reverse. Okay, reversing of R. So as a linear increase, R like the radius will be decrease. Okay, will be decreasing. So now as you can see, all of them has plus one. Okay, all of them has plus one. Okay, all of them has plus one. Now we need to compare between CL, PR. Okay, CR and PR. Now as you can see, PR is larger than CL. Okay, PR is larger than CL. So now we have two PR over here, right? We have two PR. So RB and CS, which one did the bigger? Okay, which one that larger? Okay, CS is the largest one. Okay, so now we just need to like we just need to put in order. Okay, put in order to see which one that what can I say, which one that has the lowest one. Okay, which one that has the lowest lattice energy. Okay, as you can see, PR is larger than CL. So let me see. Okay, so PR is larger than CL. Larger ion, lower lattice energy. So CRPR is the biggest one. CRPR is the biggest one. Okay, so CSPR is the large because the CS is largest, so it has the lowest lattice energy. And then how about the was that now after that is RPPR. Okay, because PR is larger than CCL, so CL the highest one, so the correct answer will be B. Okay, now number 2. Which ionic compound has the largest magnitude um, lattice energy? Okay, the concept. Higher ionic charge and smaller ions, okay, will will have what's that? So the bigger and smaller, okay, like I mentioned, higher ionic charge, okay, high charge, higher charge. I mean higher charge, and then the smaller ion will have the largest. Okay, now over here, Ca2 plus, K plus, Mg2 plus. Okay, now we can eliminate P. Na plus, so we can eliminate T. Now we have Ca2 plus, and then now we compare O and O. Okay, now O and O is same, right? So we compare between Mg and Ca. So which one that the bigger one? So Mg, okay, uh Mg is bigger than Mg is smaller than Ca. As you can see, if you are take a look at the periodic table, okay, periodic tables. So in the periodic table, PR, what's that? The Mg is like above the Ca, right? Above the Ca. So Ca is bigger, so Mg is smaller. So smaller one is C. So the answer will be C. Okay, just remember this one. Okay, now how many covalent bonds are represented in the formula NH4 Cl? Okay, nitrogen, remember, nitrogen in ammonium forms 4 single bonds to hydrogen. So if we write down for the Lewis structure, it will be something like this. Okay, so it will be has the plus charge, right? So each and H is covalent bond, right? The Cl minus is ion itself. Okay, it's held by ionic attraction, not by covalent bond. So the bonding between NH4 and Cl minus is the ionic bonds, not the covalent bond. So how many it is? 1, 2, 3, 4. So the answer will be B. Okay, so such as this one. And remember, all four NH bond are covalent. The connection to Cl is ionic. All right. Now move on to number 4. Which statement best describe ionic bonding in lithium fluoride? Lithium fluoride. Okay. So the positive and so ionic bonding isn't about sharing electron. No, right? Ionic bonding isn't about sharing electron, but it's about transferring electron. Okay. The real force is the attraction between the positive ion and the negative ion that forms after that transfer. Okay, so let's take a look at let's take a look at for each option. The positive and negative charge of the ion cancel out. Okay, charge canceling doesn't describe, okay, the bond itself. No. Okay, the lithium atom share one electron with fluorine atom. Like I mentioned, sharing electron describe covalent bond. Okay, so share is describe covalent bond, not ionic. Okay, for ionic, like I mentioned, it transfer. Okay, so option C, an electron is transferred from lithium atom to fluorine atom. Electron transfer is how the ions are created, not the bond in itself. Okay, the equation is ionic bonding. Okay, the last one, the attraction between ion is the ionic bond. Okay, yes, that's true. Because, okay, the ionic bond is the strong electronic attraction between positive and negative after one atom transfer an electron to another. So the answer will be D. Okay. Number like the option C, it looks like opposite, right? An electron is transferred from lithium atom to fluorine atom. It looks like the electron from the lithium should kind of like it electron transfer is how the ions are created, not the bond in itself. Okay, so the correct answer will be D. Okay, so this is the answer for each part. Okay, now let's move on to number 5. What's the formal charge on the phosphorus atom in phosphate in ion as shown below? Okay, so as I mentioned, we know that the formal charge, it's is valence, right, minus unbonding, okay, and then plus half electron bonding. Now the valence itself is P is 5, right? And then unbonding, how many unbonding? No, 0, right? And then plus 1 2 3 4 5. So there is a 10, so it should be 5. So the answer will be 0. The answer will be C. Okay, the answer will be C. Yes. Number 5, the answer is C. Right. Now, which molecule contains carbon with negative formal charge? Still same, use the same formula. CO. Okay, CO. We need to draw one by oops. What happening? Okay, C has four, kind of like this one, right? 2 and then put in here, right? Okay. So now let's take a look at from this information. Formal charge. Okay. So the valence itself is 4. Unbonding is 2, right? The bonding is 2. So wait. Okay. So unbonding, how many electron that unbond is 2, right? And then how many electron bonding? 1 2 3 4. Let me think. So O is 1 2 3 4 5 6. 1 2. Okay. Valence it's 4, right? And then 1 2 3 4 5 6 7 8. Okay. 1 2. Okay. So how many electrons bonding over here? Like half electrons bonding. Electron bonding is 4 divided by uh 2. So it looks like 0, right? But we need to let me think. Okay, I think I make a mistake over here. If C 1 2 3 4, okay, and then we have O over here CO, right? And then we put in something. O is 6, right? So 1, 2, 3, 4, 5, 6. Okay. So can we use kind of like C and like this one, and then oh, no way, there is no way. Like CO. It looks like there is something issue over here. Could be like this one. Carbon. The question is about the carbon. So carbon has 4, right? And then how many unbonding is 2 plus half electron bonding. It looks so weird. Okay, non-bonding electron, half bonding electron. Oh, oh yeah, 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 yeah. It's still 1, 2, 3, 4, 5, 6. Still 6. Oh god. Again, I made a mistake again. It should be 8, right? 1, 2, 3, 4. Okay. Oh, 1, 2, 3, 4, 5, 6. Okay. So we can bring C. CO, it will have triple bond, right? See, it will have triple bond. 1, 2, 3, 4, 5, 6, 7, 8. O, O will be have. How about O? And one lone pair. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 7, 8. It is. It's correct. So it will be have negative charge, right? Because adding one electron, and then it lose one one charge. Okay, so it will lose one charge. So 1, 2, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 7, 8. Okay, so now valence is 4 minus unbonding is 2. How about how many bonding here? 1, 2, 3, 4, 5, 6. 6 2, right? 4 minus 5, so minus 1. So the answer will be A. Yeah, that's good. So the answer will be A. How about the CO2? CO2 is kind of like same probably. CO2, it has 1, 2, 3, 4. Okay, how many valence? C is 4, unbonding 0, and then bonding is 4. So it will be 0, and so on. So just remember the concept of the formal charge, okay? And then that's all. How about the CH4? CH4 is easy, just like this, same thing, right? As long as it has kind of like four bonds, it will be same thing. Okay, all right. And then now let's move on to another question, number 7. How many valence electron are in the carbonate ion? How many valence electron? C, right? And then we have O2. Okay. Like this one probably. And then it has 2 minus, which is telling us it has how many electron? How many electron, right? So it will be something like this one and then this one. Okay, so 1, 2, 3, oh, CO3. Okay, might be just one. Like this, right? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. No. Okay, now 1, 2, 3, 4, 5, 6. So in this case is minus 2, right? So now how many valence electron are in the carbonate ions? Okay, now we need to calculate one by one. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24, 24. Yeah, 24, right? Okay, again, this is A, right? This is also A. This is also A. So it will be 24. It will be 24. Is that true? Let's check the key answer. Number 7. C. Yes. Okay. So another thing that we can do it quick, very quick. C has 4, right? O has 6. 6 times 3, it will be 8, 18. However, it contains 2 minus. So it will be having much more electron. So based on this one is 24. It's pretty easy. Which is the best Lewis structure for nitrogen monoxide? Okay, let's analyze each option. Okay, so step 1, count valence electron of NO. N itself is 5, O itself is 6, so the total would be 11. Now draw possible structure of this one. Okay, so let's take a look at based on this one. So how to know this part, I mean how to know the answer of this one, is pretty good if we know the concept of formal charge. Okay, formal charge telling us like uh If close to 0, it might be better. It might be better. Okay, so based on this information, guys, right, we can conclude that there is a should be a free radical, or there is a one atom, right, that alone, okay, one atom must have unpaired electron. One atom has unpaired electron. So for the best Lewis structure, you need to maximize octet, minimize formal charge, and represent the odd electron properly. Okay, so how about the first one? This has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It just has 10 electron, which is incorrect. How about this one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It also incorrect because let me see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It also incorrect because it only has 10. How about this one? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this one is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the answer will be C because it contains 11 electrons. So don't think too much. I mean, don't think too much. Just like thinking conservative. I mean, just think, okay, how many electron first that available over there? Okay, available over there. Okay, so now take a look at the formal charge if you want to know. So the valence electron of N is 5, right? And then how many unbond? 1, 2, 3. How many bond? 2. So N is 0. So this one is the best one. Number 8 is C. Okay. Again, the best Lewis structure N2H2 shows N2H2. So N has 5, 5. So it should be 10, right? H should be 2. So the total is 12. Okay. The total will be 12. Okay. Now, let's see. N, and then with N, right? Each N has, probably this one is H, this one also H, right? So N itself contains 5, right? 5. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 5. So it will be over here, 1. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Why it's 7? It's only 7. This is 6, 8. Okay, it's already 8. This is already 8. So if we are using kind of like this one, single bond, okay, let's do it again. N is 5, right? 5 10 H2, so 12. The total is 12. So it should be everything there is pairing. Okay, there is a pairing. So now each nitrogen has, okay, try the nitrogen together with a single bond. Attach hydrogen to each nitrogen. So it will be kind of like this one first. Okay, now if we check, like, each N has 2 electron from the N and then 2 from NH bond. So for electron, we need more electron to reach octet over here. So 1 2 3 4 5 6 7 8. Oh, this one. Okay, it will be good. So it will be not triple bond. It will be not, because if that one has and nitrogen has triple bond, then over here, so it's already 6 8. However, it's still 4, so it's impossible for each option. How about the nitrogen as single bond? Single bond, okay, one, two, three, four, four. That's 1 2 3 4 5. Okay, 1 2 3 4, and then think like this one, 5. Okay, it's still okay. But let's check the lone pair. Each nitrogen with one non-bonding electron pair. No way, there is no way. It should be kind of each nitrogen with two non-bonding. No, so the answer will be B. This one is not correct. Number 9 is B. Number 9 is not B, bro. Let me check for N2 H2 Lewis structure image. So it will be, so each nitrogen will with one non-bonding electron pair. So you mean, can I put it over here? Yes, still possible, right? Oh yeah. And double, oh yeah, why not double bond? Why I was thinking too much. Okay, so it will be C, not P. Okay, not a single bond. Okay, now what is the correct Lewis structure of PF3? P has 5, right? Okay, 5 5 5. Okay, that's good. So this one is incorrect. Okay, this one is incorrect. This one is incorrect. P is 5, right? This one incorrect. Yeah, the correct one is B. Number 10 should be B. I'm pretty sure B. Yeah. The resonance structure for benzene indicate that the bonds between carbon and benzene are identical. Bonds between carbon and benzene are identical. Benzene molecule exists as the unique structure. Yes, benzene molecule alternate between form 1 and 2. Yeah, that's true. Carbon-carbon single bonds are longer than the double bond. But it doesn't tell us about the resonance structure. Yes, so the answer will be C, right? No way. Oh, alternate. Not alternate. No, 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 not alternate. So it's always like rotating. So the answer will not C, sorry. So, and then let's take a look at the reason why. Just wanted to know the answer in detail manner. So the B option, the A option says the bond between carbon and benzene identical. Okay, this is the concept of resonance. Should be identical. All CC bond in benzene have the same length strength, which is between that of single and double bond. So the answer will be A. Why B not correct? Benzene exists at the unique structure. No, that's not what resonance mean. Benzene isn't flipping back and forth between these. It's something in between them. Okay. So eliminate B. C says alternate between from 1 and 2. Again, it's not rapidly flipping back and forth. Instead, the electrons are delocalized and the true structure is a hybrid. Okay, oh yeah, the hybrid will be hybrid because there is no kind of like specific structure like I mentioned. So it will be A and 2 in the same time. I mean, not in the same, like very fast, because it like delocalize uh again and again, right? And then a single bond, this one is correct, but it doesn't mean about the structure. Okay, all right. So also, like I mentioned, say single bond are longer than double bond. In benzene, all carbon bond are the same length in between a single and double bond. See, this is not correct. Okay. Okay, what's the bond order of the CO? So remember the concept that when you see resonance, okay, it means the actual molecule is hybrid. Okay, all the bond involved a resonance are equivalent, not switching back and forth or half and half. No, so it should be identical. Bonds between carbon in benzene are identical. That's why it can happen like the resonance happen. Okay, the resonance happen. Now let's move on to the number 12. What is the bond order of CO? What is the bond order of the CO bond in the acetate ion? CO bond in the acetate ion. So as I mentioned before, the bond order is in resonance structure is like how many bond are shared, okay? Are shared on average between two atoms due to the delocalization. Let's use the resonance structure for acetate first. Okay, you can like as you can see, so for the acetate, okay, the bond order is the total, right, number of bond divided a CO connection. This one is bond order. total number of bonds. So let's take a look at for this one. CO, okay, which total number of bond? There is one double and one single, so it will be 2, right? And then CO connection is also no, 2, and then this one 2, right? And then plus 1 3, and then CO connection is 2, right? So the answer will be 1.5. Number 12 is B. Yeah, 2.1.5. Like as you can see, guys, CO over here, right, has three bonds. Total is three bonds. How many atom? How many connection over here is 2. Okay, so just 3 bonds divided by 2. Okay, so there is total 2 CO bond in each resonance, one single, one double. Okay, across the resonance, the double bond is shared between 2 CO. So, like I mentioned, total number of bond divided by how many atoms like connected to the center. Okay, so total bond number and the number of position. Okay, bond order is total bond share, which is 3. Okay, which is 3. One double and one single, right? And then divided by total number CO connection. Okay, so there are 2 connection over here, so just 3 divided by 2. All right, number 13, Lewis dot structure. Okay, remember guys, right? Remember this one, total number of share bond. Okay, share bond, and then divided by number of like position. So in this case, CO is only has 2 position. So this one telling us about bond or order. The Lewis dot structure of ethanol is given below. Estimate the enthalpy combustion of ethanol using the bond enthalpies in the table. Okay, for this case, for this case, guys, we need to know like the equation. Okay, the equation of like product reactant or reactant minus product. So in this case, it's pretty, we already did before, right? So combustion, like I'm mentioning, so it should be reactant minus product. And then it will be different when you are take a look at from the previous like enthalpies and heat. Okay, so just remember, calculating enthalpy change using bond enthalpy. So it means like which we need to broken it. We need to make it broken first, and then after that we need to make it form afterwards. Okay. So now as you can see, just count like one by one, list bond form from product, either from product or from reactant. So after plugging all of them, we will get ended up like 4,719. This is for kilojoule for brick. Okay, for broken. And then for product, guys, it will be 5974. Okay, and then delta H, okay, will be what? Minus 1255. So the answer will be B. Okay, the answer will be B. Remember, if we are looking at, I mean, if you are facing the question about bond enthalpy, you have to first calculate for broken minus form, okay, or product, or reactant minus product. It's kind of like opposite with the previous one. Okay, if we are facing equation about bond enthalpy. Okay, for the nitrate ion NO3 minus, predict the bond energy between nitrogen and the oxygen. Predict the bond energy between nitrogen and oxygen, level A. Hmm, that's interesting. That's interesting because we need to know the number. I mean, we need to know like which one no, this one is not product, right? This the concept about resonance and bond order and how it affects average bond in energy in molecule. Okay, so first of all, eliminate incorrect answer with logic. Okay, NO3 has three resonance structure, kind of like this one. Okay, and then each with NO double bond. Okay, NO double bond. But in reality, all NO bond are equivalent to two resonance. Okay, so now guys, bond order for each NO. So just take a look at for the first one. Okay, for the first one. Okay, for the first one is double, right? And then the second one is single. And then the second one again is single. So 590, and then 222, and then 222, right? And then now we need to calculate the bond order. Okay, the bond order. How to get the bond order? So this is the new concept, bond order. So bond order, like I'm mentioning, okay, we need to take a look at like uh how many bonds. Okay, so it should be four, right? It should be four. And then how many number of position? And O, and then should be 3. So the bond order is 1.33. Okay, now predict the bond energy between nitrogen and the oxygen level A. Okay, so now as you can see, we try, this is the NO, this one, right? I label it 1, 2, 3. This is 1, and then this is 2, this is 3. Okay, now just adding all together, 4, 3, 1034. And then now, because the bond order, this one we need to divide it by 1.33. So the answer will be 3, 4, 5. Okay, the answer will be B. Okay, it's kind of like a little bit tricky for this one because it's the new concept. Okay, just remember, when resonance is present, bond energies and bond length are average. Okay, are average. Use the average to estimate the bond energy for any given bond. Okay, remember, if we are looking at or facing the question about the resonance, and then the question is about like bond energies, we need to like sum up the bonds together, and then we need to note the bond or order. Okay, and then after that we need to get the average by using this one divided by bond order. Okay, which molecule has the strongest nitrogen bond? Which one that has strongest nitrogen bond? How to do that? How to get this one? So remember, much more I to me, I already got the answer. Okay, because this one has triple bond, is already answered. Okay, much more much more bonds, okay, more bonding, bond strength increase with bond order. So triple bond is the strongest one. Okay, so the answer will be A. It's very simple. Number 15, the answer will be A. Okay, now again, ethinyl estradiol is widely used in oral contraceptive pills. Which arrow points to the shortest carbon-carbon bond in EE? Okay, let's take a look at this one is 3, right? This one is 1. This one is 1. This one is 2. So the answer is the shortest carbon, it will be T. It's very it's very silly question, guys. Okay. Okay, that's good. We understand. What is the molecular geometry around the an atom in the molecule topic? Okay, in the molecule topic. What is the molecular geometry around the N? Around the N. Okay, this one, right? So, is there any lone pair? I don't think so. Yeah, I think so. Yeah, it should be N, H, H, and then over here is C, and then there is lone pair over here. So it will be kind of like this one. So, it has 4, and then lone pair 1. Lone pair 1. The shape, if we are telling ask if we are thinking about this shape, it will be kind of this one, right? And then if trigonal planar is impossible, I think, right? We can eliminate this one. Tetrahedral kind of like this one, guys. So, and then trigonal pyramidal, it will be this one. And then there is another one over here. It might be T or A. However, I will take a look at uh this one. That's annoying. We need to remember the shape. We know that there is a lone pair, but if we don't remember which lone pair. Okay, it has 4 metric. Okay, steric, sorry. Steric number 4. However, it has 1. So the answer will be trigonal pyramid. Trigonal pyramid. So trigonal pyramid. So it will be kind of like this one. And then this one, and then this one. Okay. This is H. This is H. And then another one, it will be C. And then over here is like lone pair. Okay. Okay, trigonal pyramidal. How about the T shape? I just want to take a look at T shape. Oh, T shape is it has 2. It always has 2 uh lone pairs. Yeah, it has 2 lone pairs. Okay, let's take a look at the answer. 18. The answer A. The answer A. I don't know. Like, what's wrong? Because it has 2 lone pairs. And this one that make me confused sometimes, because we need to know, like, why T shape? It only has 1 lone pair. Yeah, it looks like 1 lone. I don't know. Let's see. Yeah, it should be D, bro. Number 18, not T shape. Okay, it should be D. Oh, no, 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 no. Number 17. Yeah, 17, good. T. Okay, sorry. Okay, I just want to. A central atom has 2 lone pairs and 3 single bond. Central atom has 2 lone pair and 3 single bond. Okay, kind of like this. So what is the molecule? Yeah, this one is T shape. Okay, just remember T shape has 2 lone pairs. Okay, just it has 2 lone pairs. That's great. two lone pair, trigonal planar. Let's see. Trigonal planar. Trigonal planar. So trigonal planar, like it has three, but no lone pair. No lone pair. Okay, it has three steric number. And then tetrahedral, it has four steric number. And then trigonal pyramidal, it has one lone pair. A trigonal pyramidal has one lone pair. If a T shape, it has two lone pair or three lone pairs. However, we need to know first, okay? Hopefully not too much. According to VSEPR, what are the approximate values of the bond angles X and Y? Okay, just remember, sometimes it's 90, 180, or 109. Okay, sometimes less than, and then sometimes 90, sometimes like yeah, most of cases is this one. Okay, I mean in most of cases like 120, 109, okay, or less 109, or less then less 90, or is there is a 90, no, or 180. Okay, so according to VSEPR, let's see. Okay, X, it will be, to me it will be 90, this one. Okay, or less than 90. How about this one? Because of there is no lone pair over here, and then it has double bond, it kind of like might be much more like not pen. I mean, it has four, right? It has four, and then there is no lone pair. It has three, and then there is double bond. Double bond. It will be 920. Yeah, it will be 920, right? Because it kind of like trigonal planar. There is no lone pair. So yeah, it might be P, so the answer. Number 19. Number 19. Why? Because like I'm saying here, let's see, for tetrahedral. This one is tetrahedral, bro. This one is tetrahedral. Okay, this one is tetrahedral, right? There is no lone pair. Okay, so yeah, that's true. This one is 109.5, and then 120. When it will be 90 if we have like steric number 5 and 6. It's sometime it will be 100, it will be 90. Okay, especially for 6, most of them like most of them has 90. Okay, so the correct answer will be D. Okay, so two hydrogen, and then the left carbon is CH3 group, the central carbon is bond. Okay, which mean tetrahedral is 109.5. The carbon double bond. Okay, then 3 plus. Okay, and it will be this one is trigonal planar, right? Trigonal planar. This one will be what? Tetrahedral. Okay, good. And then again, number 20. Which molecule has 120 bond angle? 120 bond angle. It will be trigonal. It should be trigonal planar. So, N has kind of like this, and then this. It will be, how about the okay? It will be and this one is less than 120. Now how about the EF? CO2. CO2 is O, right? And then so it has 3, right? It has 4. It looks like linear. Okay, it looks like, no, this is kind of like pent, I think. CO2. CO2 is pen or no way. CO2 is linear, bro. Okay, 280. How about the SO3? SO3. It might be like this way again, right? And then it has 2. It has two lone pairs, so it might be 1, 2, 3, 4, 5, and then it has 2 lone pair. It might be like less than 90. Okay, because it's T shape. Okay, it will be the T shape. How about the IF3? IF3. F. So it will have one like this one, I think, right? 3. And then it might be okay. Hmm. I'm still thinking like which one that the best one. Just need to take a look at more detail. Mm, but I'm still thinking maybe, let's see. So we need to have 3. Okay, this should be 3. Not this one. We eliminate this one, and then this one has lone pair. It should be not. How about the SO3? SO. Oh. Oh, it has 2, right? Double bond. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, F6, F4, 6, 7, 8. Okay, this is A. This is 4 A. A. Okay, so this should be this one. There is no lone pair. Okay, now CSCl2 has, and overall the molecule is SCl. SCl has polar bonds, okay, and overall, because is symmetry, right? So it cancel out the overall molecule, the dipole moment, the dipole, okay, is non-polar, polar and non-polar. Where is the polar and non-polar? So it should be P. 21 should be P. 20. Oh yeah. What? 21. Hmm. 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 Or because it has What the answer? Not P, bro. Okay. Oh, sulfur and chlorine have different. This is the bond polarity and molecular polarity. Okay, sulfur and chlorine have different electronegativity, so it will be polar. And then overall the molecular is, and then similar to H2O, to bond to lone pairs, because it has lone pair, bro, which is polar because the dipole doesn't cancel. Oh, the dipole doesn't cancel out, so it will be A. Okay, good. Okay, okay, I understand now. Okay, I understand now. So hmm, okay. What are the polarities of the indicate molecules? Okay, XeF2 indicate what's okay molecules. So the polarity, molecule polarities. Okay, molecule polarities. So there is a concept bond polarity. So bond polarity, as long as it has a difference electronegativity, it will be polar, right? So for molecular polarity is different again. Polarity, it will be polar if has dipole. Okay, the dipole not cancel out. Okay, now let's take a look at XeF2. XeF2. It has do they have, like, I just want to take a look at the what uh was that periodic table. So when we are facing this exam, we have to always take a look at the periodic table. Xe is egg, right? Egg e Xe is egg. So kind of like this one maybe. And then how about for the XeF2? It might be like Xe, this one, and then this one. So it has three lone pairs, right? And Fe and then FFE. Okay. And then now what's the so let's take a look at, is there any three lone pairs option? It's just two. No. Okay, no. If pen, it should be just one. Okay, so let's take a look at. Okay, three lone pairs in Xe, right? Okay, and then two opposite each other. Huh. It's kind of weird. Oh, oh, I got you. If we have the symmetry, it will be, oh yeah, it will be non-polar. Non-polar. How about the XEF2? Like, F, 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 F. Okay. And then XE. So putting together. So non-polar and non-polar. That's true. That's true. Highly symmetrical molecules. Okay. Like linear or square. This one is square planar. Okay. This is square planar. So it has lone pair in up, in the top, and then in the bottom. And then it has fluorine around the XE. And then as same as well for this one, this is the X, this is just linear molecules, right? Because it has two lone pairs over here and then one over here, and then there is two molecules over there. Okay, so 2 symmetry, so highly symmetrical. So remember, if molecule has like highly symmetrical, okay, highly symmetrical, it will be non-polar. Okay, number 22 will be C. Yes, that's true. How about the SCl? Why not? Because SCl, S is it has lone pair, right? And there are two lone pair or one lone pair. 20 on is a two lone pairs, but not once more. Two lone pair. It will be banned. And then if we have four lone pair, in this case, three lone pair. Three lone. Oh, okay, okay. This one. Okay, is so symmetrical. How about the pen? Hmm. Oh, trigonal planar. Hmm. Linear. Okay, just remember this one, guys. I just wondering, like, when is non-polar? Okay, for the non-polar, typically, okay, common nonpolar shapes is typically linear, such as CO2, PeCl2, and trigonal, planar, okay, tetrahedral, and then square planar, and then octahedral, then trigonal, bipyramidal. Okay, let's memorize this one. Linear, trigonal planar, tetrahedral, trigonal bipyramidal, okay, trigonal bipyramidal, okay, trigonal okay, that's great. Which molecule is polar? Polar. We want just we already know which one the non-polar. So Cl, 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 Cl. So this one is non-polar. Okay, because it might be tetrahedral, right? Yep. How about CS2? CS2. CS2 might be like this one. Like CO2 probably, right? Yep. So this one is linear. No. Nope. How about the pH3? P phosphor positive is 5, right? So there would be one. There would be one. That will be one in the like 5, right? 5, yes. So it will be one lone pairs. So is the trigonal pyramid, trigonal pyramid, trigonal pyramid, not P pyramid. Okay, pyramidal. It might be this one, might be. How about the PF5? Okay. Yes, it should be the same. So no, this is non-polar. So the answer will be C. The answer will be C, number 23. Yes. Which figure illustrate a p bond? P bond, it will be this one. Number D. It's pretty easy. What is the hybridization of the identical nitrogen atom? So let's take a look at. If four atom attached, it will be sp3. If three atom, it will be sp2. Two atom will be sp. So it might be this one because it's just three, right? sp2 and sp3. A is sp2, B is sp3. So 25, the answer will be B. Yes, that's true. What is the hybridization in the on the central atom in the molecule GeCl2? So how many it is? It should be 4. 1, 2, 3, 4. So 1 2 sp3, right? Because 4 atom, yeah. 26. What? sp, oh yeah, this one is 1 2 3. Yes, sp2. Yeah, that's great. Okay, it means like group, right? Group. If 5 groups is sp3d. If 6 groups is sp3d2. Remember this one because 3 group. Okay, number of group. Okay, so for here 1 2 3, there is a 3 group, so sp2. Yeah, that's great. How many p and, okay, p and sigma and p? 1 2 3 4 5. 1 2, hey, sorry, 1 2 1 2 3 4 5 6 7 8 9 10 11 12. So 12 sigma. And then how about the p? 1 2 3. So the answer will be G. How many sigma and p bonds are in the molecule shown? Okay, let's take a look at p first. P 1 2 3 1 2 3 4 5. It will be 5. Then 28, it will be C. Oh, 28 will be, oh, let me check it again. 1 2 3 4 5 6. Oh yeah, 6 over here, sorry. There are two uh there are two 6, there are 2 p, right? So now 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Which one that? Again, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 19 20. Let me see. Remember, triple bond, it consists of 1 sigma triple and 2 p. Okay, just let's count again. 1 2 3 4 5 6 7 8 9 10 plus 2 plus 3 plus. What? Let's count it again. 1 2 3 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19. What else? I don't know. Number 28. Why is difficult, bro? How many sigma? Let's count it again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 11, 12, 13, 14, 15, 16, 17. Hmm. I don't understand. Oh my god. I don't know. So the answer D, but I don't know. Like why 21? Okay, 1, 2, 3, 4. Oh god, 5. This one is CH3. Oh man. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Oh yes. And according to molecular orbital theory, F2 would 2 would F2. How many FF, right? It should be over here. Hmm. Have a bond order of 1 and be paramagnetic. So have bond order 1. Okay, number of bonding electron, right? Bonding minus anti-bonding divided by 2. This is the bond order. Okay, so diamagnetic is pair, right? Always pairing, and then all electron pair, and then paramagnetic is unpair. Unpair. So, okay, now each fluorine has 9 electron, right? So F2 will be having 18 electron. So now let's take a look at the molecular orbital diagram over here. Okay, so let's take a look at first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Okay. Now, mm, one. Okay. F is 1s2, 2s2, 2p, 5, right? 2p, 5. Okay. To be 5. Okay. Let me be 5. 1, 2. It should be 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But it should be like this. So ampere should be paramagnetic. And then the bond order. How many bonding? 1, 2, 3, 4. 4. So anti-bonding is hmm. Is this F? One, two, three, four, five, six. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 14 sih. Nine kan? 9. Hmm. Oh god. 2p5, right? That's true. So you will have 2p5. Okay. You will fill out everything over here, right? And then this like this way I'm saying like 5, 1, 2, 3, 4, 5. It will be like this, right? Bonding, anti-bonding. Bonding, anti-bonding. Okay. Based on this information, bonding, how many electrons in the bonding one? The bonding one is 6, right? And the anti-bonding is 4 divided by 2. We will get the bond order. 2 by 2, it would be 1. And then all pair diametric order 1. Should be this. If 8 minus 6. What's the 8? Why they don't count? Yeah, the answer will be A. Yeah, just remember, bro. Okay. N2 minus. N2 minus. So it will be adding 1 electron. It will be adding 1 electron. N is 2. Okay, so 1s2, 2s2. So N2 minus. Would be 4, right? One of this, it will be having -1. Okay, now let's take a look at this one first. Just put in over here. One, two, three, 4, 5, 6. So it should be 9, right? 2, 3, 4, 5, 6, 7, 8, and then 9. Okay. So how many bonding over here? 1, 2, 3, 4, 5, 6, 7, 8. 8. 1, 2, 3, 4, 5. 5. A. Number 30A. What? Let's take a look at more detail. So the bonding, how many electron in bonding? 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7, 8. All right. 1, 2, 3, 4, 5. That's weird. 1, 2, 3, 4. Okay. 1, 2, 3, 4. Oh man. Man, no way. Because in this case is adding 1 electron, right? put it over here 1. Okay, that's true. That's true. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Huh? Oh no, man. Because N2 minus. N is what? N is 7. The total will be 13 electron. It has minus. Be radical in this one part. That's interesting. Bone order. Berarti isinya yang sama. Okay. It doesn't make any sense. Oh man, this should be 15, bro. The total it should be 15. Why? Wait, 2p4, right? Eight, and then hey, what? 7. 3, bro. 3. Oh man. 1, 2, 3. 1, 2, 3, 4. 4, bro. 4. So 1, 2, 8 minus 1, 2, 3. Yeah. Good. The total of Kuning 10. Loh kok malah nambah-nambah. Yeah, if we calculate for S1, 1S1, yes, that's true. Okay, that's great. That's great. So you know, right, how to fill up this one. Again, for this concept, F2 is 1S2, 2S2, 2P, 5, right? Because 9, yes. So to fill up this one, 1, 2, and again. Is that true? So, okay, that's true. Not kind of like this one. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not like this one. Okay. Okay, just remember this one. 1, 2, 3, 4, 5. Okay, that's great. So we done for this part. It's very exhausted to finish all of them. Okay, thank you.